All right, welcome everyone. This is my 12.4 pre-class video. And I would like to start, before we get into what 12.4 is about and kind of framing that section, I'd first like to do a little bit of administrative stuff and show you a few cool things like I wanted to do kind of at the beginning of all these pre-class videos. And so one of the things that came up on Piazza, and so feel free if you want to see something else in these pre-class videos, please let me know, and I'm happy to oblige. But one of the things that came up is that someone wanted me to talk about the projects. And so I thought it'd be a good idea to spend a little bit of time talking about the projects, and then I'll get into the math. All right, so let me go ahead. I'm gonna view as a student just so you can, we see exactly what you'll see essentially. I'm gonna go to the projects here. And so yes, the projects, we can read all about them in step one. I have this kind of nicely lined out for you guys, at least I hope it is. Again, please let me know if you'd like it lined up a bit differently and whatnot. So first of all, right, the projects are optional. You can read about them in the syllabus, basically. If you don't do a project, the 5% that's attributed to the project gets distributed to some other exams and things and whatnot. And so you don't have to do these, but these are kind of some very rich questions, right? Many of the web work problems that we've written that we have for you guys, I mean, first of all, they can be computer graded, and they probably should take you on the order of 30 minutes or less in order to do these problems. But quite often, very interesting and fruitful math problems take a while, and so the projects are kind of our attempt to get these into the class, to get some maybe more interesting problems, things that really make you think, where you have to be creative and whatnot, because when it comes down to it, especially when you're doing research and whatnot, you have to be creative with these things, with these kind of quite difficult math problems. And so, yes, there's a lot of rules and whatnot down here. They are group projects, and that just kind of helps us make sure that we'll be able to grade all these things on a timely basis. We have a rubric, just to give you an idea, and this is not like a super strict rubric. You can see that you get some points for mathematical logic, you can get some points for the accuracy of the final result, and you get some points for presentation, right? And so you get 35 points maximum. Over the summer, we had something fairly similar, and the grades were pretty good on these things. So, but of course, it does take time. Of course, if you only put in an hour or two into these things, then you submit it, you're probably not going to get a very good score. I mean, you could, but it's less likely. The idea is that you should meet with group mates several times. You should discuss ideas. And especially when you have these tough problems that require you to be a little bit creative or think outside the box, right? I recommend that you take these in several steps, right? Read and try to understand the problem, maybe do a specific example, right? Especially if it's kind of vague, try to put some numbers to things and just see kind of what's going on, right? Why would the problem be true or not? And then maybe the next time, the next day, try to prove it in the general case. And again, continue to talk with your group mates, bounce ideas off of one another. It's a great resource for kind of these tougher projects. And then, yeah, kind of we have some great suggestions down here as well, which, I mean, largely go over what I just said, along with some others. So once you understand the projects, you can go ahead and choose a project. The projects all have their own unique due date, I suppose. And so here's project 1, project 2, right? You can see the due dates, project 4, so on and so forth. So you need to make sure that you have those turned in by the due date. You probably saw, right, if you turn them in late, you can turn them in 24 hours late, but you get a grade penalty. And after that, you can't turn it in at all. So make sure you turn them in on time. This is where you go to join a project group. I've made a separate video kind of about that. In fact, we should see it. Yes, there it is. A separate video about that. And yeah, of course, you should communicate with your project group, all that sort of stuff. And then this is where you go to turn it in. So that's a little bit about the project. So again, if you have any questions about those, feel free to throw them on Piazza. I'm happy to answer anything about those. Now let's move into 12.4. In fact, I'm going to take a sip of coffee here, and then we'll move into 12.4 and the pre-class video on that. Well, this is the pre-class video. What I should say is the ideas and thoughts, kind of behind 12.4. And so I'd like to start off with a fairly natural question, I would say. In 12.3, we talked about if you have a couple of vectors, one of the things that you could ask about these couple of vectors is what's the angle between those vectors? And that's an extremely natural question. The other thing that you could ask about these vectors, right, is if you took scalar multiples of these things and you added them together and whatnot, you could ask about all the places you could go with these two vectors. And it turns out when you do that, you basically form a plane. You can go anywhere in this plane by doing multiples of these vectors, right? If you kind of double this one, you could go over here to this point. But right, you could never kind of go outside of this plane. There's kind of a dimension somehow that you're missing, right? This has maybe length and width, but it doesn't really have height to it. And so the question that we want to ask when you're given two vectors here, what dimension are you missing, right? Kind of what is the height, or another way to say this is, what is a perpendicular vector to these two vectors, right? Because that perpendicular vector will get you into that dimension that kind of you're missing. And so in this case, you can see over here what my vectors were. I have the red one here is -1, 1, 1, and the blue one here was 1, 0, 1. And again, kind of you can go anywhere in this plane, but you're going to have a hard time escaping it. So if you want to make it into space, a perpendicular vector to this is going to be 1, 2, -1. And so let me go ahead and include that. And so you can see, hopefully if I can line this up, maybe you'll be convinced that it is indeed a 90-degree angle. It's perpendicular to this plane. And no matter kind of how you look at it, maybe like this, again, you can see it's 90 degrees. Over here, again, you can see it's kind of 90 degrees. So this right here, we will call this a normal vector. It's perpendicular to these other two vectors, or it's perpendicular to this plane here. And so that's the question that we ask, and that's the question that the cross product solves, right? If you have two vectors, what's a third vector that's perpendicular to both of those? It's perpendicular to the blue vector, and it's perpendicular to the red vector, right? And so the question is, right, how do you come up with these numbers here? And so the final part of this video, because of course you'll get into the specifics of how do you find this and some other problems that you can solve with this information in class. But the last thing that I want to show you is determinants of 3x3 matrices. So I'm going to go ahead and stop sharing here, and I'm going to start sharing with my iPad. 2, 1, there it goes. Switch over here. And I want to give you a definition for a the determinant of a 3x3 matrix. And it turns out that this has something to do with these normal vectors, with the cross product. And so if I have a matrix here, and I want the determinant of this 3x3 matrix. So I have entries A, B, C, D, E, F, G, H, A, B, C, D, E, F, G, H, I. There we go. How do you come up with the determinant of this matrix? And then maybe I'll do one mini example here. Okay, so the way that you do this is we're going to kind of go across this first row here. So maybe first off, we start with A, and we're going to cross off this first row and first column. And so then we're going to have A times, and you do these kind of, you look at kind of the smaller things that weren't crossed out, so E, F, H, I in this case, and you're going to multiply together the diagonals. So it's going to be E times I, and then F times H, and you're going to subtract them away. And of course, you have to maintain this order here. So it's going to kind of do this diagonal that's top left to bottom right, and then you subtract away the diagonal that's top right to bottom left. And then you continue this. So let's go ahead and move across. So next up, we're going to move across this top row. So we did A, now we do B. So this is going to be B times, and we look at those things that weren't crossed out. So in this case, D, F, G, and I. And again, these kind of make some diagonals. So we could do DI minus FG. And then finally, the last one here. Oops, forgot to actually do the crossing out. There we go. And let's see, so we have C times and DH minus EG. So again, you kind of always subtract away these things. And so the question is, well, how do you combine these terms right here? And so you do the first one, and this is going to be positive, and then you have negative, and then you have positive. And so maybe a fun thing that may come up in class, especially in the more theory-based class, right, is why does this go plus minus plus, or where does that come from? So if I wanted to write it on all one line, let's see here, I'm going to go ahead and copy this and paste. So on all one line, it looks something like this. I moved my parentheses. Silly technology. I can't really fit it on all one line. I guess I could get rid of this plus here and move this over a little bit. There we go. This is what it looks like on all one line. So this is the definition for the determinant of a 3x3 matrix. And again, you will need this in order to calculate out that normal vector, that perpendicular vector. And so let me show you a quick example of this, just to kind of get us practicing, right? Because this has a lot of variables in it. Let's do something with specific numbers. So I'm going to do 1, 0, 1. Let's say 2, 3, 4. And let's see, 0, 5, 0, or something like this. So I want the determinant of this 3x3 matrix. And so let's go ahead and I'll go down the list here. So first thing, first row, first column, we have the number 1. And so we're going to have 1 times, and let's see, we have 3 times 0, that's 0. 4 times 5, that's going to be 20. There we go. Now we have the minus. Remember, it goes plus, minus, plus. So now the next entry. Oh, this one's going to be very nice, right? Because we have 0 times, and 0 times, who cares, right? 0 times anything is 0, so that's very nice. But actually, it would be 2 times 0 minus 4 times 0, so it'd be all 0 in there too. So, okay, fine. And then finally, the last bit here. Crossing off this first row and third column, we're going to have, let's see, 2 times 5. Oh, sorry, I forgot my 1 here. 2 times 5 is going to be 10, minus 3 times 0 is going to be 0. And so the determinant of this matrix is, let's see, negative 20 plus 0, or minus 0 really. And then let's see, plus 10. So my final answer is negative 10. So this is how we do determinants of 3x3 matrices. And again, we will use this in order to come up with this normal vector here. So, all right, I hope this has been useful, and I hope this makes, class make a bit more sense when you're kind of learning all this sort of stuff, and kind of things digest a little bit easier. I know kind of just choosing this to go over, maybe this doesn't make a whole lot of sense. It's just kind of a standalone thing, but when you go to class, you will build on this, and you will need this information. Again, hope you guys enjoyed, and I will talk to you later. Thanks.